Dear students, under the topic vector differentiation, in this video we are going to learn how to find the angle between two surfaces. So when we are given two surfaces, the angle between the two surfaces is given by cos theta, where theta will be the angle between the two surfaces, and that is equal to the dot product of the gradient of each of the surface, that is nebula phi 1 dot product with nebula phi 2 divided by the product of the magnitude of the two gradients. So remember, in the numerator we have the dot product between nebula phi 1 and nebula phi 2, and in the denominator we have the product, the normal mathematical product between the two magnitudes of nebula phi 1 and nebula phi 2. So using this formula, now let us solve the problems under this topic. Now here the question is to find the angle between the surfaces x square plus y square plus z squared equal to 9 and z equal to x square plus y square minus 3 at the point 2 comma minus 1 comma 2. So let us see how to do that. For that, first we shall write the first surface phi 1. So the first surface phi 1 is equal to x square plus y square plus z square, and bringing this 9 to the left it will be negative 9. So this is the first surface. The second surface is this, that is phi 2 is equal to, we shall write this x square plus y square, and bringing this z to the right it will be negative 2 minus 3, and this will be the second surface. So first we have to write the two surfaces. The next step is we have to take, let theta be the angle between the two given surfaces, and we know that if theta is the angle between two surfaces, then cos theta is equal to nebula phi 1 dot product with nebula phi 2 divided by modulus of nebula phi 1 multiplied with modulus of nebula phi 2. So let us take and write this formula. So I have taken and I have written that formula here. Now in order to find this, we should know what is nebula phi 1 and what is nebula phi 2. So from equation 1, nebula phi 1 will be equal to, we know that nebula phi 1 will be dou phi 1 by dou x I vector plus dou phi 2 by dou y, phi 1 j vector plus dou phi 1 by dou z k vector. So this is by the formula of the gradient. So using this formula, this will be equal to, now what is dou phi 1 by dou x? We can directly write here. If you take equation 1, you have to differentiate this partially with respect to x. All these terms become 0 as they will be treated as constants, and the differentiation of x square is 2x. So you will have 2x I vector plus dou phi 1 by dou y. So you differentiate phi 1 partially with respect to y. So x square, z square and 9 will become 0, and the differentiation of y square is 2y. So 2y j vector, and then dou phi 1 by dou z. So differentiate this partially with respect to z. So these three terms become 0, and the differentiation of z square is 2z. So you will have plus 2z k vector. So this is nebula phi 1. In a similar way, we have to find nebula phi 2, and that is given by this formula. So the same formula, instead of phi 1 you will have phi 2, and that will be equal to, now we have to consider equation 2 and differentiate it partially with respect to x. We get 2x. So 2x I vector. Partially differentiating with respect to y, we get 2y. So plus 2y j vector, and partially differentiating with respect to z, all these three terms become 0, and differentiation of z is 1, so it will be minus 1. So minus k vector. Now we have to find nebula phi 1 and nebula phi 2 at the given point. So what is the given point? 2 comma minus 1 comma 2. So at this point, now we have to find nebula phi 1 and nebula phi 2. So let us do that. So nebula phi 1 at the point, the given point is 2 comma minus 1 comma 2. So at this point will be equal to, so here we have to substitute the value of x, y and z. So at the place of x we have to put 2, so it will become 4I vector. At the place of y we have to put minus 1, so it will become minus 2j vector. At the place of z we have to put 2, so it will become plus 4k vector. So this is the value of nebula phi 1 at that given point. And the value of nebula phi 2 at the given point 2 comma minus 1 comma 2 will be equal to, now in this we have to put the value of x, y and z. So value of x is 2, so 2 times is 4, so 4I vector. And the value of y is negative 1, so it will be minus 2j vector. And we do not have a z over here, so we need not worry about it. We can just write it minus k vector. So now we have obtained nebula phi 1 and nebula phi 2. We should also find nebula phi modulus of nebula phi 1 in order to substitute in this formula. So modulus of nebula phi 1 will be equal to square root of, here we have 4, so 4 square, here we have minus 2, so minus 2 square plus 4 again, so 4 square, which will be equal to square root of 4 square is 16 plus 2 square is 4 plus 4 square is 16 again, which will be equal to square root of 16 plus 4 is 20, 20 plus 16 is 36, so square root of 36, which is equal to 6. So therefore nebula phi 1, that is modulus of nebula phi 1 is equal to 6. So this we have obtained. In a similar way we have to find modulus of nebula phi 2. So modulus of nebula phi 2 will be equal to square root of, here we have 4, so 4 square plus minus 2 square, but here we have minus 1, so plus minus 1 square. So that's equal to square root of 16, 2 square is 4 and minus 1 square becomes plus 1. And this is 16 plus 4 is 20, 21 plus 1. So square root of 21. So this can be written as, we cannot simplify it further. It will be square root of 21 only. So therefore modulus of nebula phi 2 is equal to square root of 21. So this also we have obtained. So we have nebula phi 1, we have nebula phi 2, we have modulus of nebula phi 1 and modulus of nebula phi 2. Now all these four can be substituted in this formula in order to find the angle between the two surfaces. So let us do that. So now here we have taken and written all the values that we have obtained. Now we shall substitute in this formula. So cos theta will be equal to, first we have to write nebula phi 1, which is this. So 4I vector minus 2j vector plus 4k vector. We have to take dot product with nebula phi 2, which is 4I vector minus 2j vector minus k vector. The whole divided by, what is modulus of nebula phi 1? It is 6 multiplied with modulus of nebula phi 2 is square root of 21. So from this cos theta will be equal to, we have to take the dot product in the numerator. I have already told you, if you want to take the dot product, you should multiply only the component wise, that is I vector with I vector. So 4 multiplied with 4 is 16. Because when I vector is multiplied with j and k, it becomes 0 in dot product. So therefore I vector dot I vector is 1. So therefore 4 times is 16. And then we have to multiply the second component, which is jth component, that is minus 2 multiplied with minus 2, which will become plus 4. And then we have to multiply the kth component. So 4 multiplied with minus 1 is minus 4 divided by 6 square root of 21. So plus 4 and minus 4 gets cancelled, and this becomes 16 divided by 6 square root of 21. On cancelling we get 2 8 times is 16 and through 2 3 times is 6. And therefore cos theta will be equal to 8 divided by 3 square root of 21. We are concerned about the angle. So therefore we have to find theta, which will be equal to, taking cos inverse on both the sides. Here left hand side cos inverse of cos theta will be theta, and on the right it will be cos inverse of 8 divided by 3 square root of 21. So therefore the angle theta is equal to cos inverse of 8 divided by 3 square root of 21 is the required answer. So I hope you would have understood how to find the angle between two surfaces. In our next video we will solve more problems under this topic. Thank you.